Thank you. I hate to be the last person between you and whatever party that you have planned for later today, but welcome. I'm going to start with ChatGPT. Ever since ChatGPT came out, it allowed us to experience the power of foundation models and through a conversational AI interface, through a chat bot kind of interface. And ever since then, it doesn't matter whether you are a CIO or a CTO, whether you are a technology leader, a developer, or a machine learning expert, all of us are asking the same question. What's weighing on our mind is, how is generative AI powered by foundation models is going to transform our domains, is going to transform how we build business application, our jobs, and our industry as a whole. So today, I'm going to talk about how AWS can help you all in that journey. Okay, so when you look at generative AI, which is powered by these foundation models, there are some core tasks that you could do. Core tasks like text generation, Q&A, entity extraction, summarizing large reports, entity extraction, classification, sentiment analysis. So you're thinking, how are these basic tasks going to help you build business solutions? So, talking to enterprises, big and small, and talking about these core tasks and how to apply them together in combination to solve business problem, there's some emerging patterns, some trends that we can see, and I've put them in 3 buckets. The first one is, a lot of the enterprises are using those tasks in some combination to enhance customer experience. Things like putting a conversational AI interface grounded in your enterprise's knowledge bases as a source of truth, and then doing things like Q&A, research, providing an assistant to your internal employees or external customers. The second bucket, just an example from that, is providing intelligent search to your employees so that they can find information quickly. They can summarize large amount of information quickly. They can generate content, generate the first draft, whether that's an email or a report or an incident breach report, whatever that might be. The third bucket, to give an example, is around business process automation, business process optimization. That doesn't matter which enterprise you're in, there is a lot of documents that come in the form of legal documents, contracts, security and risk, compliance documents, and we need to go through that and assess against our enterprise's checklist. So sort of like an expert analysis. So you can see how those core tasks are being applied to these 3 buckets. But at the end of the day, you have been in your domain for the longest. You understand your domain the best, you are the subject matter experts, and you have access to the enterprise data, which is the key differentiation here. So what we're going to do is look into how these tasks, these core tasks, and these bucket of use cases can be used for your specific enterprises, for your specific businesses, where you're seeing these problems, you can formulate these problems, and you can think about how Gen AI can help solve. What AWS can help you with is to remove the friction, to remove some of the obstacle that you run into when you go about that. So as I mentioned, at AWS we've got a deep and wide set of services. You can see there are 3 stacks. So our philosophy is that you can't have one-stop shop. You can't have the one tool for everyone. So based on the persona, based on the audience type, we have an offering, a layer. So the top layer is primarily for the analyst and the knowledge worker. The next layer is for builders and developers who may not know anything about machine learning. All they want is an API to incorporate Gen AI functionality in the application. Today, we're going to spend most of the time on the 3rd layer, which is the data scientist and machine learning practitioner. This 3rd layer gives you immense flexibility, and it gives you a lot of options, and with that comes a lot of responsibility. Our focus is going to be on SageMaker, which you can see and on the right side. And SageMaker is an ecosystem of services. The 2 that we're going to focus on is SageMaker Studio, which is an integrated development environment, and SageMaker Jumpstart, which is like a model library, a model hub, where you will be choosing these foundation models. Okay, so you're the domain expert, subject matter expert. You saw some of the tasks that you could be used. Now you want to pick a foundation model, you understand the problem, and you have some idea of how generative AI can solve that, how the foundation model can solve that, and you want to start off with the experimentation. So when you start off looking at a use case, some of the metrics that would go through your mind is, what is the context size? When I ask a model to perform a task, what is my input going to look like? How big is my input going to be? What is my latency requirement? Do I need it to be real-time, synchronous, where I need some sub-second latency, or can my use case accommodate for a longer latency? One of the things that's coming up more and more is sustainability. If you pick the biggest hammer, it doesn't necessarily mean it's going to be financially viable for your use case. So you want to make sure the model that you pick is financially viable for your use case. All right, so let's jump into it. How can we pick the model? So what you're seeing here is SageMaker Studio, the integrated development environment, and it allows you to use the familiar Jupyter Lab interface. There's a couple of other interfaces that are made available depending on what editor or what editing style you might have. There is a no-code, low-code option with Canvas. And then if you look around, down further here, you can see Jumpstart. That's the model library, the model hub. It comes with hundreds of models. So if I open that up, you can see different providers, Hugging Face, both public and proprietary, Meta, AI21 Labs. You can see models from Cohere, a multimodal model which takes both prompts and images input, like from Stable Diffusion, from Stability AI, and models from AWS. So you can see all these different foundational models, hundreds of models that are available. I have picked Hugging Face here. You can see 300 plus models that are available. And what you could do is, even though these foundation models can perform multiple tasks, but depending on your use case, you want to pick the right tool for the right job. You may want to be doing embeddings, where you want to do vectorization of your knowledge base, or you might be doing text classification. So Jumpstart allows you to pick the model that fits your use case. You can also, you may want to fine tune your model, and we'll go into a bit of that. So you can sort of browse and slice and dice and pick a model that fits your use case. Once you open up a model, it shows you what the model is about, how to use it, how to fine tune it, and it gives you an opportunity to deploy it within your privacy and security of your AWS environment, completely isolated from the internet. So let's pick a model. We'll pick Flan T5. The reason why I'm picking Flan T5, it's a small model, 3 billion parameters, and it gives really decent results for things like entity extraction, sentiment analysis, Q&A kind of use cases. So what we're going to do is deploy that model. So all you do is you just click on that button, and we're deploying the model, you give it a name, and you pick the instance size. What is your load that you want to handle? Based on that, you might pick a different instance size, and then you deploy the model. So that's simple as that. So you don't have to worry about containers and burning a container and installing the right libraries. All that's taken care of. You just go into Jumpstart. Jumpstart would pick the container, bring it down into your environment, spin it up, and your endpoint is up and running. Here, you can see that we're looking at the deployment, current deployment, and Flan T5 is coming up. Let's pick another model which we'll be using later in the day. It's called Stability Diffusion. It's a multimodal model. You give it a text and a graphic input, and it gives you a graphic output. So again, very straightforward, very simple way to spin it up. You pick it, you give it a name, you give it the instance size, and then you hit the deploy button. For some of these models, you may have to accept the EULA, the agreement, the licensing agreement, before you can deploy it. Once you do that, then you can deploy the model. So you can see the two models are there and they're being created. They'll take some time to come up. While they're coming up, you might be saying, okay, I want to do this programmatically. So one of the ways you could do that is we will use our notebook-like experience. It's called Studio Classic. So we'll open that up. So you can see your Jupyter Lab notebook experience. The first line talks about the model. The model that we're going to pick, another popular one, is from Meta, Llama, with the 7 billion parameters. And then we will execute that cell, and we will use the SageMaker SDK to deploy that model. Why would you want to do it this way? Say you're designing it in an event-driven manner, you want to spin up on a particular event, you want to spin down on a particular event, so you have the choice of using those SDK to spin up your model, bring them up and bring them down. Now you could see that the 3 models are coming up, and during this session we will use some of these models. Okay. So your model is up, you have a use case in mind, you understand the problem that you're trying to solve, the business problem. The next thing is, what are the tasks that you're going to use? And then we come to the topic of prompt engineering. So when you use these models, you guide the model in the right way to perform a particular task. The analogy that I like to use is that it's like telling a kid, like a high school kid, when you want them to do a job, like people who have kids would understand this. The first option you have is you go and you do zero shot, which is you just tell them what to do. Can you do this task? Sometimes that doesn't work. Then you do one shot where you go, okay, I'll give you an example how this should be done, right? And then you ask them to do the task. Sometimes with kids, that doesn't work. So you got to give them many examples. So you give them few shots. And the last one is, you want them to think. So you go, okay, break it down step by step and then perform the task in steps. So you tell the model how to do it. So this is prompt engineering, nothing new here, something that a lot of us have to get familiar with so that we can guide the model in the right manner. Okay, so again, go back to the SageMaker Studio. We'll have a look at our models that we were spinning up, the 3 models. We can see that all the 3 models are up now. We will be playing around with the Flan T5 model because, as I mentioned, it's pretty decent for sentiment analysis, Q&A. So here we plug in the name of the model at the first cell. We execute that, set up some logging so that we get some printouts while we go through this notebook. And then the third cell is just some utility function to send the call, do an API call to the model invoke endpoint, and then when we get back the response, parse it and remove the response from it. The first task is zero shot, where we give it a story between a fox and a crow, and then we ask the model to infer who got cheated. And if you read through that sentence, it's basically the fox cheated the crow and got the cheese, right? The next one we're doing is sentiment analysis. So the question is, this product is fine so far, and we tell the model, tell me whether the sentiment is good or bad. It says it's good. One of the things we look at the parameter temperature. When you call these models, temperature is basically telling the model how creative the model can be. These models are sequence to sequence transformer model. You give it a sequence, your prompt, and it tries to predict the next word and the next word and the next word. So what we're saying is when you do your prediction, make sure it's factual, so that's when temperature is close to 0, as you saw. Next task is some text generation. Here, we say a university has a new facility coming up, write an article. In this particular case, the temperature is 0.9 because we want the model to be a bit more creative. We don't want it to be way too factual. So we set it to 0.9. There's certain other parameters, top K and top P, again, sequence to sequence model. So what we're trying to do is telling the model how to pick the candidate set of the next words to pick from. Top K, pick the top K based on probability. Top P, based on the cumulative probability, stop after you've accumulated 0.95, for example. So in this case, you can see an example where it came back with some description of a new facility. Right, and then next we're doing is translation. You can see that the temperature, we've set it to very low because we want factual information. The next task is Q&A. You've got a long chat history between an agent and a customer. The customer's got an iPhone problem and they're talking to the agent to resolve it. You can read through the whole thing, or you can get the large language model to basically summarize and find the answers. The question was, what were the troubleshooting steps that were taken? You can see force quit the app, reset setting, restart the iPhone. So some of the suggestions that was given by the agent were extracted out of that big, long paragraph. So this is how you can think about how can you apply that use cases to a problem, business problem that you're trying to solve. Next question is, did resetting the iPhone to the default setting, did that solve the problem? And it said, no, it didn't solve the problem. So you can see how you can take really long text and be able to do Q&A. Right. Next example is, so that was zero-shot learning, one shot, where you give an example. So here, we're doing entity extraction, and we give some examples. We actually give a few examples, and what we're trying to do is find the subject from the main character from a sentence. And for the first time when we try it, it gave us Sarah, which is wrong. It should give us Susan. So we changed the temperature. So that one thing you got to care about is hallucination. So you got to play around with some of these parameters when you build out your use cases. Another example is classification. We give some examples, we give it a sentence, and then we go classify this. We give it an example in the business context, technology context, sports. Finally, we give it a song, and we ask it to classify it. We run it through the model, and it comes back and it says, this is hip hop. Even though the model has not seen hip hop in our prompt, but it was able to pick it up by using the foundation model, the power of the foundation model. Last one, again, very similar, where we give it a lot of text, and we tell it these are the categories that we want you to classify some of the text that we're giving you. For example, it says just experimenting with content generation. That's a long form generation category. Then we're talking about receipt extraction, that's information extraction. The last task, the actual task that we give it is creating a useful content for company website article. And when it runs it, it says, hey, this is a long form generation. So that's the category that it puts it in. So you can see how we didn't have to train any model, we're just using the same one foundation model to perform many tasks. So that's one of the power that foundation model gives you. And prompt engineering can give you, you can go quite deep into it. There's a lot of sophisticated ways of improving the results that you get from your prompts as a result of your prompt, and how you can avoid hallucination. I've listed some of them, and depending on your model, you assign roles. When you start off, you say you're an expert legal advisor, you're an expert teacher, and then you sort of give examples, few shot, you use XML to encapsulate your examples. So you sort of have to guide the model just like a kid. I mean, just if you use that analogy, it sort of helps a lot when you build out your use cases. Okay, so you've picked your model, you've done some experimentation with your use case, but when you build your application, it's not going to be just a large language model. You have to have different components to build it out. Here I've put some big buckets. So you've got, on the left, you've got the intelligent processing. Your data might be image or speech, so you may want to convert it from speech to text or image to text. You might have some knowledge bases. You might have, and then you obviously have your large language models that we're looking at today in SageMaker Jumpstart. So you'd probably use a combination of these to build your use case. Now, when we build our use cases, and when we go and show it to our business stakeholders, communication is key. And as soon as we open our Jupyter Lab notebook, we lose our business audience. We want our business audience to be engaged so that we can get their buy-in, we can get their investment. We can push the use case forward, and then that brings in more investment. One of the things that I've been playing around with is Streamlit to quickly render your use case with a decent front end so that you can capture the imagination of your business and analysts and your stakeholders. Streamlit, the beauty is it's in Python, so you're using Python in your notebook, you can use Python in your front end, to build your front end. One line of Python, you can take a pandas data frame and you can dump it out in a nice GUI, for example. One line of Python code in Streamlit, you could set up widgets like checkboxes, select boxes. We will be using these select sliders, text input, so you can all the different kind of inputs that you would want to take in, compose your prompts and send it to your large language model. You can use file uploaders. I'll show you some examples how I use the file uploader. The other one is chatbots. Everyone's building a chatbot. You've got widgets to help you build a chatbot, and we'll see some examples of that. Let's say a use case is a mortgage use case where you've got a document, which is an image, and you want to extract key information out of it, and you want to do some due diligence, or you want to do some normalization. This is a payslip from a company, any company. The employee is Nikki Wolf, senior lab tech, base salary is 100K. Some of the information scattered across in this document. So here's the Streamlit application that I've built, and I've used those widgets that you saw. I've already uploaded that payslip PDF, and you can see it down the bottom. It's come up in a data frame. As a data frame, I've sort of printed it out, pretty print. I'm going to go into the Gen AI section now, and I'll pick the payslip, and that has extracted the text out of the PDF using intelligent processing. And now I'm saying who's the employer. So I can now do Q&A using natural language. Who's the employer? Who's the employee? Nikki Wolf. What is Nikki's salary or role? So you can see how just by using basic Streamlit, I am showcasing a use case to my stakeholders, which is a little bit more engaging compared to a Jupyter Lab notebook, right? So what is Nikki's base salary? 100K. And then with that intelligent processing component, you might need other things like AI-driven translation. You may have text in other languages that you may want to translate. You may want to extract key entities out of your document. So here's an example where we're extracting key entities out of the payslip. So it goes and extracts all the different entities and it categorizes the companies, the occupation, the person, date, location, date. So it's sort of done all that extraction for you. And then one of the other use cases, PII detection. Sometimes when we're building use cases, sometimes when we want to test things out, we want to redact PII, we want to check if there's any PII in it, so you could do that. Here's another quick example. Instead of taking a PDF, we'll just grab some article from the web. So we'll just grab an article from the web, and we will go back, put it in, and this would then summarize that article, and once we've summarized the article, it'll come back, it'll give us a summary, and then we will do similar things. So here's a summary of the article, so you don't have to read the whole thing, and the next thing is detect key entities and detect sentiment. So it detects all the key entities in that article, and then you can do detect sentiment, where it detects sentiment around each of the identified key entities and the overall sentiment. So you can see the overall sentiment is neutral, but the sentiment around some key entities is negative, mostly negative. Okay, so that's that. Here's the example of how the code looks like, as I showed. That's the file uploader that you saw in Streamlit. Just one line and you upload your PDF. The data frame dump, that is dumping the files, if you remember. So that's the upload facility, and that's all the dump of all the files that we have uploaded so far. Just one line of Python and you get a really nice GUI. Here we have the chatbot interface that you saw, where we were using chatbot to ask questions around who's the employer, who's the employee, and then expressing that as a conversational AI interface. So you could see how we're doing that, using the chat message call, one-line chat message call that you can see here. And then you can sort of say which part is the assistant and which part is the user. So you could see all of that got rendered through those lines of code. You could literally build these front end within a couple of days or even less, right? The last bit is calling out the underlying large language model. So you can see there's a function called generate response, and when I call that, it's going to, the same one that you saw previously, where we're composing the payload and we're creating the invoke endpoint, we're calling it, passing in those parameters, and then when we get a response back, we're extracting the response back. All right, let's have some fun with Gen AI. We're using the multimodal model, which is the stable diffusion that we spun up, right? We've input my picture, and then we're giving it a text. We're saying, all right, can we render this image watercolor painting wide color palette? So, and then I've got a strength slider, how much of the image to use and how much of the prompt to use. So it comes back and it modifies that image. Who said engineers can't have fun? So this is what I do in my spare time, using a large language model. Okay, let's say I want to give a different prompt, which is super smart intellectual, resembling, I think it was George Clooney, right? Because I can. I don't know if I want to consider a career change, but let's see how that goes depending on that output. So you can see there's a little bit of George Clooney in there. Okay, so maybe we can change it around a little bit. Maybe give less importance to my picture and more importance to the prompt. So this is like prompt engineering and changing parameters. So I go in there, and all right, not that much different, but getting there. Let's try something different. Let's try Brad Pitt. Maybe it matches better. I think that's much better. I think, right? So maybe I have a chance. All right. So you have your models, and you're experimenting with prompt engineering, and you're seeing some hallucination coming back. One way to avoid that is to ground your use case in your knowledge base, right? In your enterprise's knowledge base, and that's what we're going to be looking into. So here's an example where we're setting up SageMaker again. We're going to use Llama 2 7B model. So we're going to run the first cell, and then the endpoint is the same model that we spun up in the first part. It's a 7B, it's not a huge model, it's a smallish model. 7B, I mean look, all models are large language models. We're talking about trillions versus hundreds of billions versus single digit billions. And now what we're doing is just setting up some utility functions so that we can send input into the model and get back output and parse that output. And then we create an endpoint. The other thing we're using is LangChain. So have a look into LangChain that can speed up your experimentation. It's a library that allows you to integrate into models, not just from AWS, but from different providers, different cloud providers, different model providers. It also lets you connect really quickly, interface with knowledge bases, databases, and things like that. So we're using that LangChain to build it out. And in this case, we set the temperature to pretty low, so we want more factual information. We don't want the model to just come up with creative output. And the question we ask the model is, how is bias handled in SageMaker? So here, we are using the knowledge already stored within the model in terms of the model weights. It comes back, not a really great output you could see. It's here and there. What we're going to do now is we're going to attach a knowledge base. In this case, I'm using a service called Amazon Knowledge Base. And what it does is, you just point it to your knowledge base and it does the typical chunking and embeddings and vectorization for you, so you don't have to worry about it. You just attach it. So this is the PDF file that is in that knowledge base. It's got all the different information about SageMaker and it's got the FAQ on it. And you can see it's got some description about how bias is handled in SageMaker. So you could see that. So what we're going to do is we're going to give that to the Amazon knowledge base. That service does all the heavy lifting for you. It does the chunking, embeddings, vectorization, store it in the vector DB. Then we'll use LangChain to create a chain. Here's the prompt. Given the following information from the knowledge base, answer the question. And the question is, how is bias handled in SageMaker? Down the bottom, you can see the chain. Setup and retrieval from the knowledge base, pass it into the prompt, pass it into the SageMaker large language model, and then put it out in the parser. So you can see it comes back and it gives you a decent answer, better. Now I'm going to use a slightly bigger model and see what difference does it make. So generally, if you're doing a lot of generation, you may consider a bigger model. But if you're doing entity extraction, sentiment analysis, so you can see how the model is the answer is a lot more richer and it's using information from your knowledge base. You can see how it sort of goes into a bit more detail. Okay, so that's that. Next is fine-tuning. For some reason, you feel that attaching knowledge like we did using that RAG approach doesn't work for you because the model may have a very small context and you're supplying a lot of knowledge in and it can't handle it. You may consider, how about we embed the new knowledge inside the model? My advice is try RAG approach, which is attaching your knowledge base to your model, instead of embedding the knowledge as model weights within your model. Because sometimes when you fine tune, the burden goes higher on you, right? So you have to checkpoint your data that you've used to fine tune, you got to checkpoint your model's version, you got to save it in your model registry. But again, there's something to consider. We're going to use GPT J6B model, 6 billion parameter model. So here on the left, you could see an example where we're setting the temperature to quite high because we want generation. And then it's a legal use case where we give it a part of a sentence, His Honor Judge Richards, and then we call the model, and we get the response and we print it out. You could see that the response is pretty bad. As I said, the model is like a sequence-to-sequence transformer. You give it a prompt, and it tries to predict the next word and the next word and the next sentence and the next paragraph and so on, right? So, and then on the right side, we have fine-tuned the model, and you have to go through the typical machine learning process. You know, you get the data, you clean the data, you train your model, you test your model, validate, deploy, and iterate. So it's a quite intensive process, and you can see how once you fine-tune the model, the context that you're providing is still pretty small, but you get an output that is a bit more in line with the use case that you're trying to do, right? So that's an option that you have. Cool. Now, all the different examples that I showed you today are on GitHub, open source on GitHub. So you could download them and you can practice it, you can play around, you can use that as the source of your projects and your use cases. The next step that you have after that is think about a business use case. Think, because you're the domain expert, formulate that problem and experiment with it. At AWS, every second month, we run immersion days. Keep an eye out for that. Full day, hands-on, where we go through the 3-layer stack, all the way from your analyst to your knowledge workers down to your ML practitioner. Every second month we run it. Full day you come and do hands-on. And then we have specific team, depending on the use case, we can get those teams to help you out, build a prototype or a POC. And then if you want to learn and be curious, as engineers, we have to do that all the time. And if you want to go dive deep, and if you want premium content, make sure you have a look into skillsbuilder.aws. Some really good content there. And with that, thank you for your time. Hope this was useful, and yeah, enjoy the rest of your summit.
Thanks, Valal. Great day great session to end the day with. So that's a wrap for today. Tomorrow we have the Innovation Day, so that's level 100 and 200 content, so more introductory content. If there's some stuff you've seen today you think, oh, I haven't heard of that service, I want to dive a bit deeper on it, we'll cover that in more detail tomorrow at the Innovation Day. We do have drinks and food coming at 5 o'clock, so hang around for the networking hour. It'll be great to grab you and have a chat, and if you see me, grab me and have a chat. Thanks very much, see you tomorrow.